Module 3, Lesson 9. We are still adding fractions today. However, our objective is to add fractions making like units numerically. So what we have been using is our area model to make fractions. And now we're going to start using a standard algorithm, right? So we're going to do it with numbers instead of with models, okay? But we'll ease into that slowly, all right? We'll ease into that slowly. So please open up your Learn book, Lesson 9, problem set. So what we're going to do is we're going to make like units and then we're going to add. Okay, so for the first one, let's do it how we have been doing it with our area model. Okay, and I want to create common denominator. So here I've got 1, 2, 3, and here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Good. Okay. And now I have to cut this one in 7. So I'm going to cut that in 7. So 1, 2, 3, 4, 5, 6, 7. And what I've done is I multiplied both the top and the bottom by 7 to get a new equivalent fraction, which is 21 over 28. And here I have to multiply this one by 4. And now I have 4 over 28. Okay, now I have two common denominators, so I can add my units. 21 over 28 plus 4 over 28 equals 25 28ths. Okay, great, perfect. Now we're going to do it. We are going to skip the model this time, and we're just going to do it with numbers. Okay. We're not going to use our area model. We like it, we know how it works, it helps us visualize it, but now we're going to move on. Okay, so 1/4 plus 9/8. Well, I need to find a common denominator here. Okay, and I want to find the lowest common denominator. I see 4 and 8. So first we're going to practice some skip counting, okay? 4, 8, 12, 16, 20, 24, great. Now I want to try some skip counting for 8. 8, 16, 24, 32, 40, and I can keep going for both of those, but I'm going to stop now. And I see some likenesses here. I see some things that are equal. I see 8 and 8 there. I see 16 and 16 here. And I see 24 and 24 here. Okay? And if I multiplied 8 times 4, I would get 32. I could put that one there too if that makes you feel good. Let's see. This would be 28 and then 32. And then I would also have 32 as a common denominator. Okay? But I want the lowest common denominator. So the lowest one, the first one, is 8. Okay? So I've got 1/4, and I created some space there, plus 9/8 equals. Now I already have an 8 there, so what do I have to multiply this times to get an 8 here? What would I have to do there? What would I have to do? I'm going to try multiplying by 2. Okay, so 2 on the top would be 2, and 4 times 2 on the bottom would be 8, and now I can bring down that 9/8. And now I can solve pretty easily because I have a lowest common denominator, 9, 10, 11 over 8. Now that is an improper fraction. So I want to change it into a mixed fraction. So I can split that apart, 8/8 plus 3/8, right? 8 plus 3 is 11, right? And then I could change 8/8 to 1 and 3/8. So I did all of that and I didn't use my area model here. Instead, I only used numbers. So only numbers. Let's try the next one. Okay, 3/8 and 3/7. So I want to find a common denominator here. So I'm going to skip count by sevens. 14, 21, 28, 35. What comes next? 42, 49. This is why your math facts are so important. 56. 7 times, let's see, 7, 14, 21, 28, 35, 42, 49, 56. Next would be 63. Okay, and I can keep going. And now I'm going to do, that was sevens, now I'm going to do eights. 8, 16, 24, 32, 40, 48, 56, 64, 72. Okay, do I see it? I see one right there. So there's my common denominator. And I think it's my lowest common denominator, isn't it? Yep, right there. Okay. So 3/8 plus, I left space on purpose, 3/7, and I'm going to leave more space, equals, okay. Now I'm going to have to multiply this by something to get 56, because what I want is 56 down here, right? And I want 56 for both numbers. Okay. So 7 times 8 and 7 times 3 would give me 21 over 56. Okay, and here I'd have to multiply by 8, and here by 8. So 8 times 3 is 24. Now I have 21/56 and 24/56, and I can just add those together. 21 plus 24 would be 45 over 56. Now, can I simplify that? Can I simplify that? In fact, I can. I'm going to show you how I can simplify that. Both of those numbers, wait a minute, can I? No, I don't know that I can actually. I was going to say by 9, but that's not going to work, is it? Nope, that looks like that's our answer. Okay, and D, 4/9 and 4/7. I'm going to give you kind of a cheaty way to do it here. Okay, I'm just going to multiply these two. Instead of going through the whole process of finding common denominator by skip counting, I'm just going to multiply the two numbers by each other. So 4/9 plus 4/7, and 7 times 9 is 63, so I'm going to end up with 63 plus something over 63 equals. Okay, so in order to do that, I need to multiply 9 times 7 and 4 times 7. Well, 9 times 7 is 63. And 4 times 7 is 14/28. Okay. Okay, and here I'm going to multiply by 9 and this by 9. So 7 times 9 is 63. And 4 times 9 is 36. Now I can add those two numbers together. 36 plus 28. Let me just quickly do this over here so I don't mess up on the video. Otherwise, my brain math sometimes gets a little confused when I'm doing other things. 12, 13, 14 with 1, and that's 6. So that is 64 over 63. Well, we can definitely simplify that. We could definitely simplify it because 1 equals 63 over 63, and we'd have 1 over 63 left. So we could easily just call this 1 and 1/63. Okay? All right. Next one, E. I like that black. It's very bold. Okay. Again, we're going to just multiply our denominators. So 1/5 plus 2/3 equals, and I think we're going to come up with denominators that have 15 in the bottom there. That's going to be our common denominator. So 5 times 3 and 1 times 3 would give us 3 15s. And then here I'm going to multiply by 5. So 5 times 2 is 10, and 3 times 5 is 15. So now I have 13 15s. Great. Next one. 3, let's see. Do you know what? I think I want to, for this one, I want us to do some skip counting again, okay? 4, 8, 12, 16, 20, 24, and here I want it 6, 12, 18, 24. So if I multiplied 6 times 4, I would get 24, which is right here. But I do have a common denominator that comes earlier, 12. So we're going to use our lowest common denominator, our LCD, lowest common denominator, which is 12. 3/4 plus 5/6 equals, and I want my common denominator to be 12. So 12 and 12. I just found that out by skip counting there. So to get to 12, well, what makes 12? I would have to multiply 4 times 3 to get 12. So whatever I do to the bottom, I have to do the top. 3 times 3 equals 9. And here, 6, well, what can I multiply there? I don't want to multiply 4, that would give me 24, and I want 12. So I'm going to multiply by 2, and that equals 10 over 12. Now I can add those together, and my answer will be 19 12s. And I can simplify that because I know, right, I know that 12 12s plus 7 12s equals 19 12s. So I'm going to change that to 1 and 7 12. That's my final answer. Okay. Next. All right, I don't think skip counting is going to do me much good here, and I just know that from experience. We could do it, or we could just multiply these two together, and I think that's probably going to be our best bet here today. 2/3 plus 1/11, and I'm going to multiply them together. That would give me 33, and over here, this would be also 33. So 3 times 11 and 2 times 11 would be 22 33s. And here I'm going to multiply by 3, and then multiply this by 3, and that would be 3 33s. Now I've got 22 plus 3 is 25 over 33. Cool. Next one. All right. Ooh, they threw in a whole number there. Okay, so 3, 4 plus 1, and I'm just going to split this out, plus 1, 10. And you know what? I could multiply them by each other and get 40, but I think there's going to be a lower common denominator, the lowest common denominator. So I'm going to skip count. 4, 8, 12, 16, 20, 24, 28, 32. Okay, and then we could just keep going. And then by tens, I would have 10, 20, 30, 40. Do you see it? Do you see the lowest common denominator? Okay, it's right there. 20. So I'm going to use that lowest common denominator to find our answer. And let's see. So if 20 is the number I want, make 3/4, make a space, oops, plus 1, and I don't need a space after that one because I'm not going to change it, and then 1/10, and then a space, and then equals. Okay, so if I want this to be 20, 4 times what equals 20? 4 times 5, so multiply the bottom and the top. That's going to give me 15 over 20, and I'll keep the 1 as a whole number. Now here, to get 20, I would just have to multiply it by 2, and I have 2 over 20. Now I can just move that 1 over here, 1, right? And then 15 20s plus 2 20s equals 17 20s. Okay, cool. Whitney says that to add fractions with different denominators, you always have to multiply the denominators to find the common unit. For example, 4 and 6, you would multiply 4 times 6 to get 24. Show Whitney how she could have chosen a denominator smaller than 24 and solve the problem. Well, we just did that, you guys. I think we are jumping ahead of them a little bit. We just did it. So we're going to show them again with our skip counting how that works. Okay, so 4, 8, 12, 16, 20, 24, okay. And of course, skip counting, you can keep going forever. Then 6's would be 6, 12, 18, 24, 30, 36, and then we could keep going. And we have 2 common denominators here, 24 and 12. Okay, do we have to use 24? No, we don't. We can use 12. So 1/4 plus 1/6, and if we showed that with our common denominator, here we said 3, and here we said 2, we've got 3 12s plus 2 12s equals 5 12s. There, we just showed her she doesn't have to use 24 if there's a smaller common denominator. Okay, the least common denominator is what that's called. Least, as in the smallest. Least common denominator. Great. And number 3 and 4, let's see, that's it then, right? 3 and 4. Jackie bought 3/4 of a gallon of iced tea to the party. Bill brought 7/8 of a gallon of iced tea to the same party. How much iced tea did Jackie and Bill bring to the party? We might as well write in here all together because we can tell already that that is an adding problem. Let's show a tape line here. Jackie brought 3/4. Bill brought 7/8. What we want to do is figure out how much they brought all together, so that's definitely going to be adding. 3 4s plus 7 8s. Well, I can already see a common denominator here. Can you? Can you see that common denominator? So instead of going through the whole rigmarole of making a model, I'm just going to multiply that by 2 and that by 2. Okay, and then I'm going to bring it down. So 3 times 2 is 6, 4 times 2 is 8, plus 7/8, I don't have to do anything to that, equals 6 plus 7 equals 13/8. And I already know that 8/8 equals 1, and 8 plus 5 equals 13. So I know that 1 and 5/8 is my answer of a gallon. Okay. Jackie brought 3/4 of a gallon of iced tea. Okay. And Bill brought 7/8 of a gallon of iced tea to the same party. How much iced tea did Jackie and Bill bring to the party? 1 and 5/8 gallons. Okay. Jackie and Bill brought 1 and 5/8 gallons of iced tea. I know you guys like Nestea. It's probably a Nestea. Okay. Number 4, Madame Curie, who was a very famous scientist, made some radium in her lab. She's actually the scientist who discovered how to make X-rays. So you can thank her when you break your bones. Okay, Madame Curie. And she found radium, which is a chemical. Later, when we start doing mixtures and solutions, we'll talk about all the different atoms, and radium is one. She used 2/5 of a kilogram of the radium in an experiment and had 1 1/4 kilogram left. How much radium did she have at first? Okay, so she used 2/5 of a kilogram, and then she had 1 1/4 of a kilogram left over. We want to know, how much did she have to begin with? Now there's an extension, we'll try that after. Okay, if she performs the experiment twice, how much radium would she have left? Okay, so we're going to do that too. Let's do this first. How much did she start with? So we want to add 2/5 plus 1 1/4. There's our problem. But we need common denominators to add those two. So 5 and 4, we can just multiply those together and get 20. So 2 times 4 and 5 times 4 would be 8/20. Plus, I'm just going to put the 1 in the middle there, 1, plus 1/4. And I'm going to multiply that times 5 and get 5/20. And my answer will be 1, there's the 1, and 5, 6, 7, 8 is 13/20 of a kilogram. That's how much she started with. Okay. If she performed the experiment twice, how much radium would she have left? Okay, that's our extension. Let's do that one too. I'm going to switch to green. If she performed the experiment twice, how much radium would she have left? So if that's how much she started with, (1 13/20), and she did it twice, so that would be 2/5 and then 2/5, and then we don't know what that is. Well, we can just add that right away, can't we? Can't we just call this 4/5? And then we have our question mark here. So now it's a subtraction problem. So it would be 1 13/20 minus 4/5. Oh my gosh, that's subtraction. That's why it's an extension problem. So what do we need here? We need a common denominator, right? So let's multiply 5 times 4 to get 20. Let's do that, 4. And then we're going to make this 16/20. So we have 1 13/20. Okay, well, we could use our rectangular models, 1 like we did last week. 1 13/20, and then subtract 16 from them. Or we could turn 1 13/20 into an improper fraction. I think that's going to be a little bit easier. So you know that 1 equals 20/20 plus 13/20 would equal 33/20. Okay, so now I can just change this to 33/20 minus 16/20 would be, let's see, 12, 17/20 of a kilogram. If she performed the experiment twice. Does she have enough to perform the experiment twice? Absolutely. She sure does. She could actually perform it a couple more times, I think. Cool. Okay. That was Madame Curie. Her name was Marie Curie. Now, please go do your exit ticket. No story problems, just making like units and then adding. Now, I don't want to see your area model here. If you want to use it on a scrap piece of paper to check your work, you can. But your exit ticket should show me only numbers. Only the numbers. Okay? Very good. After you finish that, go back and start your lesson 9 homework.